Our video for today is called the cosine ratio. And our notes for today are going to look identical to our notes from the sine ratio for the most part, because we're still asking the same questions. So for instance, in your notes from last day, you're going to see this picture. And I'm going to ask you, well, to find angle A. And if we were going to find angle A, what would you do? Well, hopefully now the question is becoming a lot easier. You'd use the tangent ratio. And when you set up your tangent ratio, what do I know? You'd get the tangent ratio is 6 over 11. And in order to solve that, you would press this button with this ratio on your calculator and get the answer. If I asked you to find angle A given this picture from last day, what you should recognize to do is to use the sine ratio, because I have the opposite side of the angle. So we want to find angle A. And I have the hypotenuse, and that's what I use. Opposite over hypotenuse is sine. And in this example, the sine of angle A is equal to 6 over 14. 6 over 14 is the sine ratio. And we would find angle A by pushing the inverse sine button on our calculator. And that would tell us the answer. And if I wanted to find side x, in this question, well, again, what do I have? I have an angle, I have a hypotenuse, and I want the opposite side. So as with your homework, classwork, textbook work, from the last section, we use the sine ratio. We'd set it up, and we'd solve an equation. And there are only 3 kinds of equations. We've looked at the 2 of them here, when the unknown is in the angle, when the unknown is in the unknown is on top, and when the unknown is on the bottom. So I'm hoping you're recognizing you're doing the same thing with a different ratio. Okay, so will any of these ratios, the tangent or sine ratio, allow us to solve these 2 questions? Angle 40, side 5, x. So what do I know? Well, I know angle A. I know the hypotenuse, and I want to know that side right there, which relative to angle A is not the opposite side, it's the adjacent side. And what I hope you would recognize is none of the ratios you've learned so far have an adjacent compared to a hypotenuse. So we do not have opposite adjacent, that's the tangent ratio, or opposite hypotenuse, that's the sine. So no, nothing we know right now is going to allow us to solve that. Well, what about this one? We have A, we have B, we have C, and what I want to know is, I want to know angle A. So, okay, what do I know or want to know? Well, I know the adjacent side relative to angle A. I know the hypotenuse, and I want to know angle A. And again, what I hope you recognize is we have adjacent and hypotenuse information. So we do not have opposite, adjacent, or opposite hypotenuse information. So no. But what I do hope you recognize, if you wanted to, in this last example, we could always use Pythagoras to find that unknown side. And once we have the unknown side, we could then use sine or tangent. But again, just like last day, that's way too much work. Too much work. Well, we don't need to do that work because there is a ratio with right triangles that works when we have the sides adjacent and opposite to the angle. So if we label our triangle ABC and label, well, there's my hypotenuse, and relative to angle A, this is the opposite side, and relative to angle A, this is the adjacent side. Looks familiar? We've done it 3 times now. Well, if we have information about the side adjacent to the angle, we know, and if we have information about the hypotenuse, we can't use any of those other relationships. What we can use is something called the cosine ratio. So the cosine ratio of a right triangle is the relationship between the adjacent side and the hypotenuse of a particular angle. And this is the last of the basic trig ratios. Okay, let's look at some examples just like last day. Determine the cosine ratio. The cosine ratio is just the comparison of the sides. So even though we write it all out, if I asked you, what is the cosine ratio for angle A? Well, I'm not going to write it all out this time. I'm just going to tell you that the cosine ratio of angle A is 5/13. It is the ratio of the side adjacent to the hypotenuse, 5/13. For angle B, well, the side adjacent is 12 and the hypotenuse is 13. So these are the ratios. Now, the reason it's nice to actually write that equal to cos A and write that equal to cos B is now the only thing you can do with this is find the angles. And that's where you push buttons in your calculator. And that's example 2. So given the cosine ratio, cosine of angle A is 4/5, determine the angle, sketch the triangle. The sketch is important, so let me sketch it right off the bat. Here's angle A, here's the side adjacent, and here's the side opposite. In the end, they represent the adjacent over the opposite. Now this picture isn't drawn to scale, but if I did use Pythagoras, this side would be 3. So right now you should be able to tell me something about angle A. And what you should be able to tell me is it's less than 45 degrees. It's less than angle B. The side opposite angle A is 3. The side opposite angle B is 4. 3 is smaller than 4. Therefore, angle A should be smaller than angle B. Now again, this is what I mean about in class when I say you need to have an idea what your calculator says. So in order to find an angle, we always push the buttons. And in this case, the appropriate button is the cos to the -1 of 4 divided by 5. And when we press that, we'll end up with, well, we'll round it to 37 degrees. And again, as I said, that will be smaller than angle B. Angle B is going to be 53 degrees. So again, the button to push when you need to solve this particular equation. Let's do 2 quick examples. Again, they're looking just like what we've done over the last 2 days, but that's a good thing. Determine how long x is. So we might want to highlight right off the bat, x is the hypotenuse. It's opposite the 90-degree angle. Right away, in my head now, I'm going, oh, well, I'm not using the tangent ratio. But let's go through our process. What I know. Well, I'm going to call this angle A. I know an angle. I know a side adjacent to that angle, and I want to know the hypotenuse. And again, what that does is that points me to the cosine ratio. This is why it's important to write down what I know. Get it out of your head. Well, what's the cosine ratio? The cosine ratio is the ratio of the side adjacent to an angle over the hypotenuse. Given we have our formula, if you want to think about it that way, we can plug things in. Cosine of 70 is equal to 1.5 over x. So in the examples we did above, on the previous page, we didn't go ahead and solve, but this is the third of the kinds of equations I've been asking you to solve. And the shortcut for this one, remember we did the algebra in class, but the shortcut is interchange the cosine thing and the x. And when you do that, you get this. And remember, cosine of 70 is just a number. It's the ratio for every triangle that looks like this. So in our calculator, we can simply push the buttons and get to one decimal place, 4.4. meters. Okay, let's do this one. Determine the indicated angle. Now remember this thing here. You've been seeing it in your homework. I've been talking to you guys in class, but that's just a Greek letter, theta. So in trigonometry in the future, you're going to see a lot of Greek letters for angles. If you don't like it, change it. It's called an angle A. So what do I know about this triangle? Well, I know the side adjacent to angle A. I know the hypotenuse, and I want to know the angle. So again, no shocker today. What this points us to is the cosine ratio. So it's the cosine ratio. The cosine of an angle is equal to the side adjacent to the hypotenuse. Now it's Fisher-Price math time. Plug the right thing in the right spot. Over 4.2. Use the inverse button, the cos to the -1 button on your calculator. And when you do that, you get second cos 2.1 divided by 4.2, 60 degrees. So the cosine of that relationship is equal to 60 degrees. Angle A is equal to 60 degrees.